Okay, so what we're going to do tonight is we're going to do two things. I want to cover something called views, and I want to cover indexes. Okay, I don't think we haven't done views, correct? Yet?
Nope.
Yeah. Okay. And indexes, I know I keep talking about, but now I'm going to actually do it, and then I'm going to show you how you should create indexes, because some people think that just they know how to create indexes, but they don't necessarily do it quite well. So what we're going to do is we're going to start with the indexes first, and I'm going to give you an example first, show you how it works, and then give you a strategy for the indexes so that you can see how it goes. All right, so here's my database. Again, we're going to use the same employee database that we have here, and you're going to see here we have the salaries table. This is what I want to focus on, okay? Now, if I do a query for the salaries, and I basically run, this, it takes 0.0093 for the duration, and then it has to go fetch it. So the duration is it's preparing the query to figure out what to do, and then what it's going to do is it goes and fetches the records. The whole purpose of this is to reduce the amount of time it takes to do the queries. Now, we're going to do this with one table, but where this really kicks in is when you have multiple joins. Because if you consider the fact that if you have like 3 or 4 joins like we had in the past, you're going to end up with a situation where you have one join which has to go get the data, another join which goes and gets the data, then it has to decipher what it's pulling from those 2 tables, and then it joins to another table, and so forth. You're going to hear this term full table scan. A full table scan means in order for me to find the records I need, I have to go through the entire data, the entire table. If you have 2 tables that are joined, I'm going through one table and another table in order to make sure I have all the records. This is what we call expensive. It's slow, okay? If you see here, when I do this select star from employees, okay, salaries, you see this button here with the little magnifying glass? This is what's called an explain plan. Now, I'm not an expert in reading explain plans. There are people who do this for a living. I don't, but I know what I'm looking for. So when I click this, you're going to see here that it says, oh, okay, this query executes a full table scan. So what it does is it's going to have to go through all the records in order to find what you want, and it gives you a cost, which is $5,74711. Now, I don't exactly remember I think that's in cycles, but I don't remember what the number is. It doesn't really matter. I'm really concerned about this one, so it's going to scan 2.8 million rows in order for me to get one. So I'm going to do something that, let's see if I can do this. I want to find this employee number. So if I run this, you can see it's going to go through it. It took 1.1 seconds to run, and then it fetched the correct records very, very quickly. So it took me a while to run it because I had to find the records, and then the display or the fetch time to get those actual records didn't take so long. So you can see the difference between running a simple query and then having to return a whole bunch of records, 2.4 seconds, as opposed to running a query that's a little bit more complicated and it doesn't take so long to fetch the records. Now, I'm going to explain this plan. And again, you see, it actually says that there's not a difference between the full select star from employees, salaries, that query, and the one where I just want the records for 454, 447. Okay? Does that make sense? It's basically an estimate taking roughly the same amount of time as far as the explain plan is concerned. Full table scans take a long time. Does that make sense?
Can I ask 2 questions here?
Sure.
Was employee number a primary key?
No, what I did was I got rid of all keys to show you this. I'm going to show you that in a second.
Understood. Okay? And the second question is this profiling information. Can you see it if I'm doing SQL on a shell? That is, yes. I'm not using.
There's a command. I think it's called when you do the select. There's a way to put the word explain in the select statement, and it will give it to you.
Perfect.
Okay.
Yeah.
Here, I'm sorry. It's right in front of me. Explain. You finished? Okay. As soon as I'm done, I'll take a look. Okay. You see where you put the word explain in front of your query?
Yeah.
It's exactly what you do.
Perfect.
Okay. All right. So now what we're going to do is I want to show you what we did first. If you go to, you're going to have to go to each one of your tables. If you're going to do this, you're going to have to alter the table, and you have to click. If you have a primary key, you have to turn it off. So yours may look like this. You have to turn it off and click apply. When you do that, if you go to indexes, you'll see that your indexes have been removed. I actually removed all the indexes so that I could show you this from all of the tables, I think except for department employee here. Let me see if I can show you this one. Alter table. Right, see here, I have a primary key, and this primary key is what's called a composite key. Both of these must be unique in order to insert the record, the employee number and the department number. So what I'm going to do is I'm going to turn these off. And if you look at indexes, well, there's no indexes on this, but there should have been. So I turn that off, drops the primary key, and now you'll have no indexes and you'll have no primary key. This is the slow, I'm purposefully making this operate slowly so that you can see the effect of the indexes. We want to do that on salaries because we want to make sure that we have no key on the salaries, no primary key. So if you do alter table on salaries, there's no primary key and then there's no indexes at all. Okay, does that make sense, everyone?
Yep.
So if I were to go and I were to try and remove the primary keys and it would give me an error, what would be causing that?
Did you try and remove the indexes or the primary key?
Primary key.
It should remove it. Did you remove both and you clicked apply?
Yeah, I've got a primary key on employee number and date, so I unchecked those and then I tried to click apply. And then it pops up with the review this SQL script to be applied to.
Okay, do me a favor, share your screen real quick.
Sure.
Because I know you get this error with what's called referential integrity. There may be something else that we have to remove, but I thought with salaries you didn't have to do that.
Yeah, I think you guys have my main monitor right here. I think you're looking at the SQL.
Yep, click apply.
Yeah, so I just these were the ones selected, so I unclick these.
Unclick them.
Apply.
Don't move. Don't do anything.
Mm-hmm.
Do not drop needed a foreign key construct. Okay, click cancel. I need you to go to department emp, DEPT emp, alter table. Go click on foreign keys down at the bottom. Click on indexes. Go back to columns. We're going to try and remove this first. Take off the primary key here. Click apply. Good, finish. Go to employees, alter table. Take off the primary key here. I don't know if
so is it a
click apply.
Is it a sequential thing?
There's what's called referential integrity. So you've got to get rid of something first in order to do this. Go back to titles. Alter table. Take off the primary key and make sure you go to foreign keys for 1 second.
Sure.
Right mouse click on that and delete selected. Now apply. Okay. All right. Go back to salaries, alter table. Go to foreign key first. Right mouse click. Alt delete selected. Apply. There you go.
I don't think I got rid of the primary keys.
Then you can go back and get rid of them. It's just one of those things. Since I didn't create the table, I have no idea where all the foreign keys are. So you just got to go through all of them and get rid of them in order. Go ahead, click apply.
So for me, I've got all my queries on my attempt tab here.
Yep.
So after removing these primary keys and these foreign keys, if I were to go back and try and rerun them, they wouldn't run anymore, right?
No, they'll run. Your queries will run. They'll just be a little slower.
Oh.
Okay.
Cool.
The indexes and the primary keys are only there for a couple things. There's something called referential integrity, which basically means when you insert a record, right, it has to have, if there's a foreign key, it must have a corresponding foreign key. So in other words, I can't enter in someone's salary if they don't exist in the employee table.
Okay.
Okay? That's called referential integrity.
It's dependencies.
Correct.
Okay. All right.
All right. All right. So now that you've got that and you've got that removed, I'm going to share my screen. Okay. So we've done that, and here's my salaries. And again, I did my explain plan, and I see I've got a full table scan, and it takes a while. So you can you see how long it takes on the fetch time. Now what I'm going to do is I'm actually going to alter the table. I'm going to alter the table, and I'm going to create an index. I could create a primary key, which is going to automatically create an index, or I can create an index myself. The reason I'm going to create an index now is because you can create indexes that aren't primary keys. And what it does is this. Think of a book. If you're looking for a particular topic in a book, where do you go?
Index.
You go to the index, right? So you literally go to the end of the book. You look. You can easily scan for your topic, and it tells you exactly where it's located and how many times, correct?
Mm-hmm.
That's exactly what an index does in the database. What it does is if I'm going to create an index on any field, like employee number, okay, I'm going to basically say, so I click the indexes, I'm going to do no index. I have to give it a name. Doesn't matter what you call it. You could have called it kerfuffle. It won't matter. And I select employee number. What it will do is it will go through your entire database, and it will organize all of the employee numbers and basically create a reference to it to say that the anytime you look for a particular employee number, here's where you go look for it. Boom, it's there. It will look in the index first and then give you the information. Does that make sense?
Yeah. You had just said something that when you create a primary key, it already creates an index based on that primary key, correct?
If you all primary keys must be an index.
Okay. So
it's automatic.
Okay. So effectively,
I'm sorry, I lost my screen for 1 second. Oh, there we go. Okay.
No problem. So the very act of creating a primary key will optimize the search result of a table.
Say that again?
So the very act of creating a primary key on a table will optimize the search on that table. The result will be returned faster once you have set.
On that key.
Okay.
Okay? Only on that key. If your employee is a primary key, the employee number, any queries with the employee ID will be optimized.
Okay, got it. Yeah.
Okay?
Yeah.
This is what's important. What I said is when you create an index, it optimizes the query with the index, as long as the index is in your subquery. Okay?
Right.
In the where clause.
Right.
So watch.
Why is it faster than just referencing the emp number?
Why is it faster and what?
So right now we have an index that's saying emp number index. Why is that faster than just referencing emp number? I'm just confused on the broad scale here.
Okay, so here's the thing. Let's assume that you have a book of employees, correct?
Okay.
Now, I want you to find a particular employee. How are you going to do it in the book?
Okay, so you flip through the whole book to try and find the page, or you go straight to the front, find the page you're looking for.
What if it appears on multiple pages? I don't know what that is. Yamini, that's you.
Sorry.
Okay. So, Chris, can you hear me?
Mm-hmm.
Okay. So, if the employee appears on multiple pages because they've had multiple salaries, right?
Mm-hmm.
You have to go through all of everybody's salary in order to find it, correct?
Yep.
Unless you went to the index and said, I just need to know which ones this employee had.
And you pull all of them. Okay.
And you pull all the ones where it says it's here, 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 and here. Does that make sense?
Yes, yes. Weirdly, my brain just works in VLOOKUPs because that's what I work with.
No, that's fine. Okay, so here's what I'm going to do. I'm actually going to do select star from employee salaries where the emp number is here. But I'm going to do my explain plan first. Did I actually apply that index? No, I didn't. Hold on. Okay, index. Let's apply the index. Emp, no. Index. I select the columns for the index. I click apply. Run it. We wait. Done. Close. I now go to my salaries. Here's my emp number. I run the explain plan. Now it says non-unique key lookup. It's looking it up, but look at the cost. Remember the cost before?
And yeah, it was, yeah.
You see that?
Mm-hmm.
Much, much faster. Okay. Not only is it faster there, and you can see the the speed there. I will run the query itself. Look at the difference between how long the duration took here and here.
Wow.
Okay. Does that make sense?
Yeah.
This
so
is
that's
how
like more than 10,000 times.
you want to know what's funny? If you think about it, we're looking at 2.8 million rows, and the difference, you could say, yeah, it was only, you know, like 1.1 seconds and so forth, right? Mm-hmm. That's not too much. I'll just, you know, I'm okay with it, right? What if you do this?
Oh, Lord.
Actually, I gotta do this first. Let's run this. There's my explain plan. Look at the speed, right? It went up. Mm-hmm. Because I have to scan the index range. Mm-hmm. So when I run this, again, it took 0.0014. That's pretty fast. It's still faster than the single lookup that I had to do, right?
Right.
Okay, so let's play a video game. I'm going to alter the table. I'm going to remove the index. Why didn't that work? Because, hold on, kill this. Because you can't do this. You got to delete it there. Can't just take it off the. Oh, okay. So I'm going to close this. Where is this? Okay. Well. Okay, here's my query again. Now let's run it. See the difference?
Yeah.
Wow. Yep.
Okay. And that's what happens. This is where, again, both were slower. My duration was slower. My fetch time was slower, period. You may not think it's a lot, but try dealing with 20 million rows, 50 million rows, or think about what happens when you're trying to join tables. If you do some of the queries we did before, where you're trying to find things at different date ranges and so forth, it will take a while to do. Does that make sense?
Yep.
Yes.
Yep.
Especially based on the more records it's got to find. That becomes an issue. Now, one of the key things that I said was this is all based on your query. So let's take a look at something. Hopefully I've got one of these. Where is my salaries? I'm looking for one of the older ones that we did, if I can find it. Trying to get you. No. Do I have any ones of the older ones? Let's try this. Nope. No, I don't think I have any of the older ones. On one of the older tables or one of the older queries that we have, let me do this. Let me see if I still have it in Slack. Did I posted one of these on Slack, right? The loan query?
I don't recall.
Yeah, I did right here. Okay. Let's take this. Hopefully this works. I don't even know if it still works. We're going to find out. This was one of the queries that we did. Select this, case when gender, inner join salary, blah, blah, blah. I'm going to remove the index.
Oh, now I remember this query.
Oh, I'm glad you do, because I have no idea. I don't remember it. I'm just
The Bernie Sanders joke, remember?
Oh, this was the Bernie Sanders joke?
Yeah.
I'm glad you remember these things. Glad I could be a comic relief.
Oh, please, you're awesome. You're the whole package.
All right, so here. So now what I'm going to do is I've got all this stuff here. I have no indexes, or at least I should have no indexes on any of this, but I do on Department Manager. So let me alter table. I need to get rid of the primary key. Click Apply. Apply. That should drop everything. Good. Departments. I've got indexes here. So alter table. I'm so not used to destroying tables. So used to just creating them well. Okay. Apply. That should be it. I don't think I have any more indexes. I do. Get rid of this. I'm going to go over composite keys in a minute, and then we'll go over views too. Apply. Good.
So all of these primary keys exist because whoever created it already set it up this way, right?
That's correct.
So somebody actually had to go through and kind of manually do this?
Yeah, or you can do it programmatically. In other words, when you're building the query, you could do that.
Okay.
But I think before that,
I'm sorry, when you're building the database, I apologize.
right?
I knew what you meant. Yeah.
Go ahead, Vahan.
Yeah, no, essentially what I was going to say was I think there's an entire process, right? You start with the entity relationship diagram, and then you start with normal forms, and then you decide where you want to end, and then finally you then create your database schema. I mean, that's how we learned it.
Yeah, so ideally you would do all those things, but it's like I should eat vegetables, but I really don't. Okay. Look, I'll be perfectly honest with you. You know, if you could take a database course and go through proper design, you can go through what are called, for those of you who are interested, you could look up something third normal form, BCNF, which is Boyce-Codd normal form. These are very, ways to create a database so that you have no redundant data. The reality is that there's two things. Number one is purely normalized data has no redundant data except keys. In other words, so if you have students, right, I have a student ID. If I have classes, I don't put any of the student information in classes. I only put the student ID. So the only thing that is repeated in any sets of tables are keys. Does that make sense?
Right.
Wouldn't you want some kind of redundancy though, just in case?
Just in case for what?
I have no idea. I just feel like you'd want to.
You don't, because you want to minimize the number of transactions that occur. So in other words, if I'm entering records in, if I were to just put in classes, let's say band 203, Chris's ID is 1, Gabriella's ID is 2, I don't have to put your full name, your address, or any other information. I only put the key in that table, just like we did here with, in this table, you see this titles, right? All it has is an employee number. So all the employee information is tied to that employee number. Does that make sense?
Mm-hmm. Yeah.
Okay. So when you're designing a transactional system, you want it in a highly normalized form. But if you are going to be doing analysis and reporting, you want it in a denormalized form because it's faster.
I see.
Anytime you do joins, like I'm going to do here, they are expensive. Okay? In other words, it takes processing time and disk space to do so. If I were to do the explain plane here, okay?
Wow.
So right off the bat, I've got 4, I'm trying to move this for you. I've got 4 full table scans in order to do this. Okay? And you can see how large the query is, right? And how many rows this is going to be. Does that make sense?
Wow.
Mm-hmm.
Okay. So now what happens is how do I determine what my keys should be to do this better? You look at your where clause. Anything that has your where clause, and inner joins are also a where clause, okay? And I say, all right, well, the first thing I want to do is I'm going to try and figure out with any one of my larger tables, right? I want to basically just, manage this a little bit. So in salaries and employees, I really would like an index on the employee number. So what I'm going to do is I'm going to alter the table, and I'm going to put an index. I'm not worried about the primary keys, but I'm going to put an no index on salaries. Then I'm going to go to employees, and I'm going to put another one here. They can be called the same thing because they're associated with the table, so it doesn't really matter. And I'm going to do employee number, apply, close. Now I go back to my query, and I'm going to change my explain plan. Now look what happens. If you look at the two explain plans, look at the difference here, 6.95 million rows.
I think billion, it's a giga.
Yeah, actually it is, but okay, that's maybe possible because of the duplicate. So that's billion. I thought that would be an error. Look what it went down to.
Wow.
Yeah, here's the 2.16 million rows. Okay, and my total query cost here, 5489090, but over here it's 5.91 e to the 15th power. Does that make sense?
Wow.
And you can tell which one is which because it says DT, D, E, and S, and they correspond to the aliases that I have here. I went after E and S because these two are the big ones. So what I'm going to do is I'm going to go after the other one on D, which is department EP, and I'm going to basically say, okay, this one, I'm going to alter the table. I'm now going to create an index. No index. Employee number. Apply. Now I'm going to go back here. We're going to rerun the explain plan. Did I do that? Did I apply that?
A question, does the red color and the green color have any significance?
Yeah, green means there's an index, red means there's a full table scan.
Okay.
Did I do this right? Alter table. Index. Yeah, apply. Let's try this again. Huh. I don't know why this is doing a full table scan actually. Oh, I know why. Because there's the index is probably not a valid one. If you have all the records, in other words, then the index is useless. So the index may be useless in there. Each employee probably belongs to one department and only one department. Let me see. Could that be? No, it's a front.
I think there were employees with more than one department.
Yeah, so I'm not sure why that's coming back with a full table scan because I did D employee number, so that should have worked. Speed tree. Okay, I'm not really sure why it worked, why it didn't work. Anyway, you can run the query. You can see what's going to happen with the time.
Lord.
It's going to take a long time because I don't have indexes on all of them. But remember, when we ran this before, it had indexes because of the primary keys, right?
Right.
It ran a lot faster. So there you go. It took 22 seconds. Now, if I can, now this where clause on the from date, this is not going to work as an index because this is an aggregate. I could do department name. So I could basically create an index here, although it looks like there's an index on that one already. Oh, what happened? Explain plan. Yeah, this is the only one that bothers me. I don't know why this didn't work. This is on D, and D is DM number. Okay, I'm not really sure why that's the case.
Well, DT is referencing, is it because of departments? Because
no, DT is this one, the departments, but this is very fast. This is only 8 rows. This, however, is 331,000, right?
Gotcha. Yeah.
With a 47,000 cost, so that's an issue. So I'm not actually sure why that's the case, why that's causing a problem. If I wanted to, there are other things that you can do here, but I don't think this is going to affect it that much. But if you took off the indexes, if we really want to just see the timing, so which indexes did I do? I did the employee. So I'm going to remove the employee index. And remember, we said it took 22 seconds to do this, so we'll remove this one. And we will remove, because I did it again. Got to delete the index. You can't just turn it off. So we'll remove that one. Close. I will remove salaries. Index. Kill this. Delete selected. Come on. Apply. Apply. Close. And I think that's it. I did the other one for Department M, so I'll remove this index too, just for poops and giggles. Delete selected. Golly. Okay, close. Now I'll go back here. I can run my explain plan. Good luck. Just lots of numbers, right?
Mm-hmm.
All right, cool. I'm glad you like that. So now what I'm going to do is, it took 22.94 seconds, right?
It's going to take a minute or more, isn't it?
Yeah, I'll be back. I'm going to go get some coffee at Starbucks. I'll see you later.
I mean, it was, I mean, the magnitude by which we saw it before means this is going to take 5-10 minutes, right?
I don't know, 5-10 minutes.
I'm just thinking because before we saw like an order of magnitude of like 15.
I'm not sure if you should look at the scale in a linear way because your CPU also does a lot of time slicing and parallelizing. So it's not necessarily a linear decrease.
Not only that, it also depends on what's running on your computer.
Yeah, that too, of course.
Okay. So does everybody understand indexes while we're waiting for this to run? Is that anybody have any question on indexes? Cool.
Nope.
All right. So the other thing, again, while I'm still waiting for it to complete, is this. If you have a where clause, okay, let's say you have a composite where clause like we do here. Let's say I do something a little bit different. Let's say where I change this to by the way, I don't know if you can hear, but my fan just went off on my computer because the CPU is processing like crazy. Hold on one second. I'm going to stop sharing.
Yeah, that's not a good thing, by the way.
No. But I always told you, you know, I'll make your computers work, man. Hold on.
I have to say, I feel like Mac fans are so, like, Macs are great in general, but, like, the fans get so hot and they're so inefficient and ineffective.
They're actually not. They're very effective.
Really? Because
Yeah.
mine, like, gets so hot sometimes, like I feel like I could cook an egg on it if I work it hard enough.
That may be because the older computers are now using more, you're using more power, you're trying to do more than it was designed to do. So that may be the case, but no, it should be fine completely. CPU, where is my Microsoft, where's my work, where's the server? Oh, you know what? Let me see if it didn't finish. I think it finished. Hold on. Damn it. Don't finish. Oh, good. You didn't. Okay. Hold on. We're going to come here. Where the hell is it? Where is the... There's so much crap going on here. I'm looking for the MySQL on this. Activity monitor. Where the hell is it? All right, there's a command here. Okay, where is it? I got to share my so you can see my screen. share. On the desktop, on your Mac, in Windows, this is Task Manager, and you can see what tasks are running. On the Mac, you would run this by going into Terminal and typing the word top.
Yeah, you can also use Activity Monitor for those who like the GUI.
Yeah. Does the GUI give you everything?
Well, the non-technical stuff, yes, because I don't think anyone is really interested in too many CPU details.
The problem is you're gonna have to get used to this. I'm gonna tell you why. Because if you're gonna run against databases, some of them are gonna be on Linux systems. You've got to know how to go after this, this information. But they are generally the same. What's going to happen here is that you've got what's taking up CPU, what's taking up memory, and this top is kind of giving you the same thing. I don't know where my MySQL is. I think I'm missing it for some reason.
Actually, why don't you try PS aux grep pipe grep MySQL? Maybe that should show you something. Also, have a look at htop while you're at it. It has a much better interface than top.
I'm old school, so.
No, it'll show you some really cool ncurses based. Okay, it's not a. Take out the minus. The minus works on the Linux bash, but on the FreeBSD bash, it doesn't.
Okay, PID. This is giving me the process. I don't think it's giving me the total.
What are you looking for?
I want to basically show that this thing is still running. Here you go. So you can see it's still running, right?
Yeah.
That query that before took 22 seconds because I put some indexes is still going on. Okay.
Right.
And there are ways to figure out, what it is actually doing here in your administration section, which you can't see. Let me reshare. In the administration section of SQL, you can go to your client connections. You should be able to see the connections. Should be this one. It's a little hard to see, but this is the query, and you can see that it's still running. It's just going to keep running. And this is how you can determine what's going on. This is some of the database administration stuff that you have available that you're going to need to know at some point. That query is just still going. What I did want to do is I wanted to say, if you're going to have something, I'm going to go back to query, where we have, let's say where we do on employees, where's my employee table, columns, can't believe the Mets are now one game over 500. All right, where employee number is equal to 55, whatever the number was.
I think there's an extra N there, EMP. Yeah.
So we did, let's say 447000, something like that. And gender equals male. Okay? And I'm not going to run this, but I'm going to show you. Let's assume that you have these two items in your where clause. If you want to speed this up, I'm done with this query. I can't take it anymore. If you want to run this, it's still going to take a while. But what you can do is you can go to your employees table, since they're both in the employees table, and you can create what's called a composite index. So I'm going to create, we'll call this index 2. And I want it to be this and gender. Now, you can have two single field indexes, and that will run fast. But if you have a composite index, it will run faster because it's going to keep track of all of the combinations of employee number and gender. Does that make sense?
Yep.
Everybody follow that?
Yep.
Your where clause, if your where clause has multiple fields, you can have single indexes, or if you needed to run faster, you would literally create a composite index. Now, some of you may ask, well, why the hell don't I just create a whole bunch of indexes? Why do you think I would say you don't want to create a whole bunch of indexes?
You won't necessarily be putting everything in a where clause.
I won't, and every index will take up more memory and more space. So you don't necessarily need it. The idea is to optimize your long-running queries, and that's what you want to focus on. You want to get it down from going from 5 minutes down to 2 to 3 seconds. And yes, that is very possible. Does that make sense?
Yep.
Mm-hmm.
Any question on indexes? No? Okay. So let me show you something about views, and then we'll call it a night. So now what I'm going to do is I'm going to create a query very quickly. Run that. There's my query. This gets all males, right? Now, if you have a very big query, like we had before with this other one, okay, and I'll run it with this, but it's going to take a little bit of time. And actually, let me do this. I'm actually going to create. Let me put back in the employee index, because we'll do both. Alter table index IDX1 employee number. Apply, close, salaries, alter table, index, IDX2, employee number, apply, we're done. Now technically that query that we ran should take 22 seconds. So let's see if it does. We'll get rid of this. Hopefully this runs in 22 seconds. While I'm waiting for that to come up, let's go back to this other one. Here's my file, my SQL file here. So I ran this employees where gender is equal to male. Now, what I can do is instead of having to type this all the time, I can create a view. The view is like a macro. So what will happen is I'm going to come down to views. Or anything in there? There is. I'm going to do create view. And I can now take that query that I just created, go back to my create view, where the hell is it? And literally paste it here. And what it will do is it's going to create a macro for me. I call it a macro. There's some more intricate stuff here. And I'm going to call it as male employees, just like that. So the male employee view is going to be all employees that are male. I click apply. And it creates my view. Now, what does that mean? Well, it basically means this. If I were to select all rows from the view, select star from employees, male employees. Notice this looks like a table, doesn't it?
Yep.
But it's not. It's a view. It executes the query and gives me whatever the where clause or anything else it was. Does that make sense?
This view is created on the employees table, basically, correct?
Yeah, well, it's based on whatever query I actually had. So the query that I had created before, right, is exactly what it is. It makes this bigger. It actually creates a more well-defined view. All I did was select star from employees. It changed to select all the individual fields from employees where the gender is equal to male, and it does this definer for security reasons. Who can have access to it?
Right, and it says algorithm undefined. I mean,
that's again, there are different ways to create views. So we didn't specify an algorithm. You can look up in the specification.
Yeah.
There's a couple different things that you can do with it, but that's beyond the scope of this.
Sure, cool. Okay. Yeah.
Now I'm going to go back to the let's see, where's the one that I did? I think it's this one. Okay. So you see this big query here? I don't even remember what the hell this did, but it took us the 27 seconds to run. Great, but you know what the problem is? This is a really big query that I just don't know. You know, I don't want to type all the time. Oops. I don't want to type this all the time. I got to get rid of this. So what I'm going to do is I'll copy this and I will create a new view. You can create as many views as you want. I'm going to paste that query there. And again, we'll call this the Bernie Sanders view. I'll click apply. Click apply. Oh, I got an error. Duplicate column name gender. Okay. So I got a duplicate column name gender. Yeah, okay. So I did it twice. So I got to call this, I can get rid of this actually. I don't need this. Hopefully this
You
works.
should take out the comma then, right?
No, I need the comma because I got another field here.
Okay.
So I apply. There we go. Now I've got the Bernie Sanders query. I could run this. You will not get any performance improvement, but notice that I just ran select star from employees.BernieSanders, which is a view. It looks like a table, but it's really a view. So it acts like a table, but it's a view. And we just wait, and you should see it will run in roughly the same amount of time.
Okay.
And that's how you create views.
One question. So
Yep.
here you did select star. If you want to access something inside the view, a specific column,
Yep.
You can do that, right?
You can now do everything that you did with a table. I could do a subquery. I could do where clauses. I can select certain fields. It acts like a normal table. You can join views to other tables. It doesn't matter.
And I can join views with other views as
That's
well?
correct.
Okay, awesome.
So what's like the difference, like the functionality difference between tables and views then?
You can insert into tables, delete, and update. You cannot do that with a view.
Got it.
That's probably the easiest way to say it. There's a slight overhead with views, as you can see. Here, it took 29 seconds, right? It's a slight overhead. It's not much, but in some databases, you have what's known as a physical view. It's actually a cached version of the table. It actually stores it in memory, so it makes it faster. MySQL does not have that, I believe. Okay?
Okay.
Mm-hmm.
Any questions? Okay. All right, so what I'd like you to do is I'd like you to try and create a couple of indexes on some of the tables that we have here, removing all of them, and then tell me the difference between, where you had a full table scan versus the performance with the query, and try and get something that will have a compound index or a composite index like employee number and titles, because, again, titles will have a certain number of items. Okay?
Mm-hmm.
So you can play around with it. Any questions on this?
Not yet, but there will be.
Okay, that's fine.
Just one question. So the code that you copied from Slack and then you dumped it in and then it took like a really long time. Why did it take a long time here and it didn't when you first wrote that?
Because there were indexes on the employee numbers, just like there are here. When I took out the indexes, it didn't even finish because I got.
Right. Okay, got it. I forgot about that part.
And you could actually try that. Let it run overnight and see actually how long it takes. Just for fun.
I'll pass.
It's important to understand how long some of these queries take, and a simple change like adding an index is huge. I'll just give you a little anecdote. I was working at a company, and one of them said basically, well, we had to do search for 8 million claims or something like that, or I don't even think it was that much, 1 million claims. And I said, okay, we should be able to, it was taking them 12 hours to process it. We should process that in under an hour, because at Credit Suisse, we actually processed 24 million trial balance records in 8 hours or 7 hours. To do a lot of work for those 24 million trial balance records, we were able to do a lot of processing in a few hours. Mm-hmm. These guys were just trying to pull records for claims, about 1 million of them, and it was taking 16 hours. So I said to them, all right, well, let me see the indexes on the database. And they go, what's an index? Okay, now I kind of have an idea why it's taking 16 hours.
Right.
And you know what we got it down to? 20 minutes.
Awesome.
We went from 16 hours to 20 minutes.
That's crazy.
That's the power of understanding how to do this. So if you're doing large end data science work, you can see how that can help you, because it's going to get you all the data faster that you need. Okay?
Mm-hmm.
Cool. So like I said, there isn't much more that we really need to do. We covered pretty much everything that I wanted to cover with indexes. You've got everything that you need on the select statement. I think we did do inserts and deletes and updates, correct?
Mm-hmm.
Yes.
Okay. We did do the views. We did the group by clauses. We did the indexes, which is huge. So what I'm going to do next week is I'll talk a little bit about stored procedures, but we won't go into it too much because it does require programming. But I will explain what they are and why you might want to use that or why you might not want to use it.
Awesome.
And then I'll let you guys, ask me some questions, or if you want to go over something specific, I'll be happy to do that.
Sounds good.
Yeah, I had a question regarding what you said at the beginning of the class. So I was interested in simulation in business, and since you're not taking that in Hofstra, at least in the near future, I would be interested if you had a class like this on simulation in business.
So what we could do is, if you want to do that, just send me a list of topics that you want to go over, and then I'll see how I can streamline them in for you. I'm going to try and do things in 4 session increments to make it easier.
Okay. Yeah, I haven't seen the syllabus of what simulation in business is supposed to cover. So do you have a copy of what you did in your previous simulation in
somewhere.
business class?
I can find it for you.
Yeah, if you can just send that over to me, I can have a look and Google and see what it's all about, and then get back to you.
Not a problem. Does anybody have any other questions on SQL? Are we good for now? Okay. So what I'll do, I'll cover next week a couple of other administrative items, and then just open the floor to questions. And then I think we'll be all set. I don't think there's anything else that I'm really going to need to cover. But again, I'll leave that up to you guys. If you want to cover some other things that we haven't covered, I'll see what, if I know them or if they're even relevant. But for the most part, everything that I use on a daily basis, we've gone through.
Mm-hmm. Cool.
It's just the practice.
It's really practice there. That's exactly it. Okay.
Yep.
All right. Is this helpful so far?
Absolutely.
Yep. Okay. No other
Use
questions? We'll go down the list again. Chris, any questions?
No, not yet.
Gabriella, any questions?
Not about this, but can I talk to you after?
Absolutely. Vahan, you good?
Awesome.
Vanessa?
I'm good.
And Jean?
I'm good.
Excellent. You have a good night, and I'll stick around, Gabrielle.
Thanks.
Take care.
Thank you. Take care.